Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 14.2, Problem 11. This is Section 14.2, it's problem number 11, and it says, what is the maximum possible volume of a cylinder made out of 600 square centimeters of stainless steel? So, you have 600 square centimeters of stainless steel to use. You want to make the cylinder so it holds as much volume as possible. So a cylinder, like a can, something like this, and we can kind of put in the part that you can't see there. And the volume of a cylinder equals the area of the circle on the bottom times the height of the cylinder. So it's that area times how high it is. So the area of the circle, which you may or may not remember, is pi r squared. So that gives you the area of the circle, and then times the height. And we want to make this as big as possible. So this is our function. What we're going to want to do is take the derivative, set it equal to 0, and solve for the variable. And like some of the previous problems, you have two variables. It looks like 3, but pi is really just a number. It's 3.14. But the r is a variable, and the h. So we need to have only one variable. So what we do know is they have 600 square centimeters altogether. So what we can do is use that to write one variable in terms of the other and then substitute it in. So in terms of the surface area of that cylinder, or how you're going to use up that 600 square centimeters of stainless steel, if you flatten that cylinder out, this is what the stainless steel would look like. You'd have a circle for the top, a circle for the bottom, and then the wall of the cylinder is really a rectangle. And all that has to add up to 600 square centimeters. So each circle has an area equals pi r squared. That's each circle. So now the total surface area of 600 has two circles, one from the top, one for the bottom. So you're going to have 2 pi r squared, right? Top circle, bottom circle. And now the rectangle that you have, the side of the rectangle is from the height of the cylinder, and the long edge of the rectangle, like the bottom edge, is the same as the distance around the circle, or the circumference, which is based on the radius. It's pi times the diameter, or pi times 2 of the radiuses. So it's 2 pi r, not squared, just pi r to the first power. So I have you two circles, top and bottom, plus the rectangle, which is 2 pi r, that's the base, times the height, which is h. So now, because that multiplies out to 600, I can either solve it for r or solve it for h. Either one can be done. The h is easier because h only shows up in one spot. So I'm going to solve for h. So to get the h by itself, let me start by taking the 2 pi r squared over with the 600. So now on the left side of my equation, I'll have 600 minus 2 pi r squared equals 2 pi r h. Now to get the h by itself, divide both sides by the 2 pi r, and it'll isolate the h. 2 pi r goes into the denominator, and it'll cancel on the other side. So h equals 600 minus 2 pi r squared over 2 pi r. Now it might be tempting to cancel the pi and one of the r's, but you can't do that because it's a subtraction in between the pieces in the numerator. If it was a multiplication, if it was times, then you could just cancel each pi. But because it's a subtraction or an addition, to cancel the pi in the bottom would have to show up in every piece in the top. So you can't. It's tempting and it would clean it up, it would look much nicer, but you can't. So h is equal to 600 minus 2 pi r squared over 2 pi r. Now that I know what h is, let me bring that value for h and plug it into my function for volume. And now I'll express the volume in terms of only a single variable, only r. So v equals 2 oops, no 2, sorry, pi r squared times h, where h I know is equal to, from my work on the left side of the problem here, 600 minus 2 pi r squared divide by 2 pi r. All this big mess here is h. So now I substitute it in. It looks worse, but it's actually better in a sense because I only have one variable, which is r. Again, the pi looks like a variable, it's just the number 3.14. So now I have my function in terms of one variable. I'm going to do the derivative, set it equal to 0, solve for, in this case, r. Now before I do the derivative, I've got r's all over the place. I can neaten this up quite a bit. So v equals, now the pi here and the pi here, that can cancel actually, because I have pi times some stuff over pi. Let's cancel that. And I have r squared and here r. Well, I can cancel the r in the denominator and reduce this to an r to the first. So now what I have is just r times 600 minus 2 pi r, and there's a 2 in the denominator. So r times 600 is 600r. And then r times minus 2 pi r squared will be minus 2 pi r. R times r squared is going to be r cubed. And now there's still that 2 in the bottom. I canceled the pi's. I reduced the r's, but that 2 didn't reduce. But now both things in the top have a times 2. So now I can do v equals, this 2 will make this 600r into a 300r. And as long as I do both pieces, it's okay. And it will bring this 2 pi r cubed down to just pi r cubed. The 2 will cancel. Now that I've cleaned it up, it looks a lot better than it was 2 lines above. So now that's what I'm going to do the derivative for. That will become v prime, which will solve pretty easily. Again, pi is just 3.14. And you can use more places after the decimal if you want to. So v prime equals the 300r will just give me a 300. Again, when you have an r to the first, the derivative is whatever the number in front is. Now this minus pi r cubed, the 3 exponent is going to come down times the minus pi in front. I'll have minus 3 pi r squared, like that. So now that's v prime, 300 minus 3 pi r squared. So now set that equal to 0. So I have 300 minus 3 pi r squared equals 0. That's an easy step. Now solve that equation. Find the value for r that makes that true. So let me bring the 3 pi r squared from the left side of the equal sign over to the right, and it'll become positive. So I'll have 300 equals 3 pi r squared. And I can reduce the 3's pretty easily. Let me divide by 3, divide by 3. So I'll have 100 equals pi r squared. And now I want the r by itself. I can actually divide by pi. I could have done it in one step. I saw the 3's first. So I will do 100 over pi equals r squared. Now, I want r, not r squared. So I'll do square root of both sides. So square root of 100 over pi equals square root of r squared. And what I wind up with is plus or minus 10 over root pi equals r. Now, because we're dealing with volume, minus 10 over root pi is really a nonsensical answer. When we have the volume of a cylinder minus a radius of negative value, it's just 10 over square root pi. And now you can get a decimal equivalent for that. But most answers, if you look in the back of a book, will leave it in terms of pi. And you can put in 3.14, and you can keep putting as many places after the decimal as you want for the amount of accuracy you need. So you can estimate it at 3 if you don't need much accuracy, or you can put many, many places after the decimal. So that's the value of r. Now, R is related to H through this equation here. So now once I have R, I can find H, and once I know both R and H, I can find the maximum for this cylinder. So I have an equation here that says H equals 600 minus 2 pi R squared over 2 pi R. So now that I know what R is, H is 600 minus 2 pi times 10 over the square root of pi squared over 2 pi times 10 over a square root of pi. So that looks kind of messy. But it'll simplify down reasonably well. So H equals 600 minus, so let me do that second power here. I have 2 pi times 10 over square root of pi second power is going to be 100 over pi. The 10 second power, 10 times 10 is 100. The square root of pi second power, square root of pi times square root of pi is pi. And then in the denominator, don't forget I have that to deal with. So I have 2 pi minus, let's see, times, where did it go, R. So the 2 times 10 will be 20, and pi over square root of pi, let's see, how do I want to write that? So that's square root of pi, you could think of it that way, 20 square root pi. Because the pi in the numerator will reduce this down to a square root of pi, and this can be simplified. So right here in the top, I'm going to have pi, I can reduce them. That's going to be 200. So I'll have 600 minus 200. And in the bottom, 20 square root pi. So now H equals 600 minus 200 in the top is 400 over 20 square root pi. And the 400 over 20, I can reduce that. So the H is 20 over square root of pi. So that big mess did reduce down pretty good. So the R was 10 over square root of pi. And the H is 20 over square root of pi. So now the volume altogether, if you remember, volume for a cylinder is 2 pi R squared times H. So let's put in the H and the R, and we'll find the maximum volume. So volume equals 2 pi times R squared. So again, R squared will be 10 over root pi squared times H is 20 over square root pi. And we'll simplify this. So volume is 2 pi. So 10 over root pi squared. So the 10 squared, 10 times 10 is 100. And root pi squared, root pi times root pi is pi. And then that's times 20 over square root of pi. So now the pi in the top and the bottom can cancel. I'll have 2 times 100 is 200. 200 times 20 will be 4,000. And in the denominator, I have square root of pi. So you can estimate that if you like. That is an answer that you could leave like that. But if you want to do 4,000 divided by the square root of pi. So if you want an approximate, it is volume equals 2256.758334. So 2256.76, a little more than 2256 3/4. And this is in centimeters, so that'll be in cubic centimeters. So it's about more than 2 liters of volume.